Okay, hello everybody. My name is Jay, and I'm here to talk about why are there so many languages? Now, just right off the bat, just want to say that this is not a technical presentation by any means. We're going to look into a little bit of the history and the modern uses of these some of the programming languages. Now, before we begin, just a little bit about myself. Again, my last name is Suthamjaru. It is Thai, and I was born in Bangkok, and I moved to Canada when I was very young, and I grew up there. I only came to Japan 2 years ago, and I came here with the human resources background and was teaching English for a while and decided to pick up coding. And that's why I'm here. So let's just jump right in. When it comes to programming languages, you have to be aware that there's kind of like two kinds of programming languages. One is low level and one is high level. For low level languages, they're made for machines mostly, which means that it's easy for machines to read. And if it's easy for machines to read, it's hard for humans to read. So which makes it really, really hard to debug. And it's not really used anymore. I put asterisk there because I don't mean that in a sense that it doesn't exist, but rather people don't code in low-level languages anymore, in most cases. And for high-level languages, something that we're used to, made for humans, it's easy for us to read, and which then in turn make it easy to debug, and is really popular recently. The easiest example to show you is when you look at the CSS code. If you see on the left side, you want to set the background color of body to red. Now that's very easy to understand. You know what red is. On the right side, that's more so a lower level language where it's just FF00. Now machines can read that really quickly. But for us, that makes it hard, of course, without the red square to it. Now, I'm gonna go over these three languages. That there are a lot more than this, but after going through these three languages, you'll probably see the trend of how these came to be. So we're gonna start with C++, but if you want to start with C++, you have to talk about C. And you can see this as like the big daddy of like the modern day high-level programming language. It was introduced all the way back in 1970s, and it was an iteration of B. Who would have thought? And it was created because people at Bell Labs, they were going to create a new operating system called Unix. And I guess people were really tired of coding in assembly language. So they decided to create something that's more legible for humans. And that's how C came to be. And it got popular when Oracle took it up and created their really, really popular database from it. And then some random teenager in a garage decided to make an operating system called Windows 1.0 from it. You can probably see why it's so popular now. And it's still being used, although again, people don't really code in it, but it's still being used. Your Windows, basically all operating systems, the kernel is still using it. If you're unfamiliar what kernels are, they're basically the lowest level of language. That's basically right before assembly. And because because it's so low level, it's most likely your appliances, well, at least like the earlier generations of appliances were coded in C. Obviously, fridges and everything now becomes like super advanced. So they're starting to use C++ now. Now, with C++, who would have thought? An iteration of C. And it was introduced in 1985 because, the creator, he was really good at Simula, a language called Simula. And Simula had this thing called classes and objects, right? It was built on the foundation of object-oriented programming. And C at that time was not. And the downside of Simula was that it was slow compared to C. And he really liked the classes and objects of Simula, and he really liked the speed of C, and he wanted to combine the two. And that's exactly what he did. And he added additional features to it, and then he called it C++. And you can see how the fundamentals of two languages are completely different, even though it's still C. And C++ is being used right now in all operating systems you can think of. Video games, there's an asterisk there. We'll come back to it later. All mobile platforms, car navigation system, like a lot of, basically any program that has to interact with hardware will probably use C++. Now I put asterisk there for video games because even though video games uses C++, or in the case of Unreal Engine or C# in case of Unity, they're actually trying to move away from the actual coding aspect of it. If you're familiar with Unity or Unreal, you know that a lot of the times now they code in Blueprint. If you can't see what the letters say, don't worry about it. You can just think of each square block as like an object or like a class or a function, and then it's being connected with graphically, right, with arrows. And this is pretty cool because you don't, if you want to make like a basic game in Unity or Unreal, right now, chances are you might not even have to code at all. And as time goes forward, I would assume that this will be a lot more complex, and maybe one day we just stop typing. Now, let's go on to JavaScript, something that a lot of us are familiar of. JavaScript has probably the most interesting history out of all of them. Okay, and we can't talk about JavaScript without talking about Netscape. Well, in 1995, web browsers are not that versatile. Nowadays, you can run anything on web browsers, like games, operating systems, Microsoft Word, Office, is anything, right? It can run on the web browser. Back then, you can't. And you also have to remember that in 1995, most people were using dial-up internet. Internets were really slow. So what happens is, let's say if you have a form you have to fill in, and let's say there's a section for a phone number, and you type in your phone number, and a form asks for just raw number, no hyphens, no spaces, but you put in hyphens. Web browsers can't check that. You have to send it slowly through the phone lines to the server, and the server checks that, and then it comes back, and then we're like, oh, sorry, your phone number was wrong. And that sounds trivial today, but back then that takes a long time. So what Netscape wanted to do was they wanted to create a small scripting language that can be run on the web browser, something really lightweight that can do kind of like these error checkings before they send it, before the client sends the data to the server. So they created Mocha. And it wasn't really like a programming language back then, so they had to change it to something like something with script in it. So they renamed it to LiveScript. Now that's not JavaScript yet. So then Microsoft at that time was also going to release Internet Explorer, something revolutionary back then. But and they had the same idea as Netscape, and they actually took a lot of inspiration from Netscape's LiveScript. So I guess in one point, there were like 2 versions of JavaScripts running around. This is before standardization. So Netscape had to partner up with Sun Microsystems, which owned Java at that time. And Java was really, really popular, but it was heavy. You know, it was capable, but you can't run that on the browser. You have to run it on the server. So it makes, LiveScript and Java kind of like the perfect partner. You have Java running in the back and then LiveScript running in the web browser. And as you can see, it's still LiveScript, and Netscape, they really, really want people to take notice of their code. So the marketing team thought, no one's going to notice LiveScript. Why don't we put Java in it? So people thought that it's similar or somehow related to Java. So they changed the name to JavaScript. If you've been listening to me, you probably realize that they have nothing in common, even their origin, but they share similar name, and that is why, because marketing. Anyway, JavaScript in the modern form, it's extremely, extremely versatile, right? And it is relatively easy to learn compared to, especially like the C. languages. And it is supported by basically all web browsers. And it is supported by the community. You go on Slack Overflow, there's like tons of people having problems with JavaScript and things like that. And you can just, you find solutions really quickly. And also people build on it, adding more features and things like that. And when they build on it, they add a huge amount of code libraries and frameworks to JavaScript. That's why it is so versatile. And what uses JavaScript is basically every website you've ever been to. I mean, there's probably here and there, but just in general, probably every website you've ever been to, and a lot of web applications are also coded in JavaScript. Now, to the cool kid in the block, Python. The history is not as interesting as JavaScript for sure. Basically, in 1980, the creator, it was about to be Christmas, and he wanted to find something to do. And he was really good at this language called ABC. And he really liked the fact that it introduces things like exception handling, try catch. He really liked that. But he didn't like some parts of it. So he thought, over the Christmas, I am going to create a new language. And he really liked Monty Python. And you can probably see where it goes from there. So Python's unique capability, I guess, it's that it's super easy to learn, and it is hugely popular because it is easy. Because it's so easy, small companies start to pick it up. It's easy to train employees with it, and it's quite capable, right? And it got really, really popular when big companies start to come in, like Google, for example, and they start to develop libraries and frameworks for it. And as mentioned earlier, right now, there's huge amount of coding libraries for Python as well. And it's so easy in Python because it's even more interpreted than JavaScript is. If you look at on the right side compared to the left, let's see, for variable JavaScript, you need to have a declaration, let. The software has to know that you're declaring a new variable. In Python, you don't need to do that, right? You just say it, and it knows. Same with the function. You have to start with a curly bracket. You have to end with one. In Python, you don't need to. It knows. And that's what it means by interpreted language. And I mean, this is super, super basic. But imagine this expanded to maybe like 10,000 lines of codes, and you can probably see how Python will become a lot shorter or like simpler looking, at least. What uses Python? Well, it's arguably the king of artificial intelligence. Okay, and basically, data science, machine learning, all the trendy tech talks and things that you hear online nowadays, blockchain and metadata and all those things. Python is really, really good at that. So in the modern day, just want to quickly go about how, like, let's say a company uses all these things together. For example, NVIDIA. NVIDIA, all of their driver code are being coded in C++. Because again, if you remember, the hardware and the software is really close to each other. So it can interact really, really well with each other. And when they reach the hardware limitation, they turn to AI to enhance that enhance the performance. So a lot of the new NVIDIA developers are actually Python developers because they're focusing heavily on AI. And this goes to a lot of other companies as well. When they want to go into AI, they really want those Python developers. And of course, you need a platform somewhere, so they have their websites and web applications and things coded in JavaScript. So it's not like a battle royale of who's better and this and that. It's just you pick the right program language for the job. So why are there so many programming languages? I think the better question to ask here is, why were there so many programming languages? I'm not saying that there's not a lot now, but there were a lot more. And really, they were born out of necessity. As you remember, C++ came because C wasn't object oriented and they want to add that together. So they created C++. JavaScript came because nothing was running on the web browser, right? So they want to add a function to a previously available code. Instead of just having a library or framework, they have to create a new language. And in the past couple of decades, some languages have shown up, but not as much. And it's actually less languages nowadays. I guess you can see this as also like a in real life too, where a lot of people are starting to speak the same language and a lot of like the smaller local languages are dying off. Similar to here, because the languages are becoming more capable, there's less need for more languages. So in the modern day, it's not so much about the capability of the language. I'm not saying JavaScript and Python and C++, they all like functions the same. They not, but I'm not going to go into the technical aspect of it. But if you want to build something, you can do it with more or less any programming language, any code. So when you look at the code, you really have to look at past the code and more so into the people around it. You know, are there a lot of people discussing about this on Slack? Are there a lot of developers actively working on new functions, new features, new frameworks, new coding libraries? And all of this makes coding much easier nowadays. So you really have to see it like each programming language as a single tool in a box. Do you want to hammer a nail to a wall? What would you use, right? You can use a wrench. You can definitely do it with a wrench, but you can probably do it easier with a hammer, right? And that's what I want to conclude with, which is that, you know, the capability of languages today is really just around the people of it. And it's really important to be part of that community as well. You know, nothing's stopping you from creating an AI with JavaScript. But if you want to do it within a week, you'll have more chance using Python and things like TensorFlow, right? You have a new laptop, a new model of laptop, you want to work on the trackpad functionality. You know, your best chance is to go with C++ and use the libraries like Cinder. Right? You want to create a website. I mean, React and Vue is, they make complex website relatively very easy, right? You can throw something together in a week. Like, that looks really good. And I'm not saying you can't do it with C++, but you know, why, right? So after this presentation, just leave with this, that, you know, you don't code alone. There's other people coding with you, working on this ecosystem of a programming language. And yes, even though there's not that many nowadays, but each language has an origin where it came from. And I guess somehow nowadays they're a lot more similar than what the creators, I'm sure, ever dreamed them to be. And that's it for my presentation. You guys can wake up now. Thank you very much for listening. You can follow me on GitHub at Jay Suthamjaru. I have a couple of repos there. And I hope you guys have a great rest of the day.